Continuing on with some more causes of common problems when it comes to storage, an array rebuild is something that you may need to do from time to time if you do discover that there's just misconfiguration or you're just having problems with the array. With this, it does increase the likelihood of a future failure because there's a lot of stress actually placed on disks when they're rebuilt or just simply placed into an array. All of the drives are formatted, and it just simply takes a long time. There's a lot of activity happening when you rebuild the entire array. So you definitely need to make sure that you have a current backup and that it was backed up successfully before you initiate the rebuild. Any kind of improper disk configuration obviously might result in drive specification error messages. Your partition table may be corrupt. You might have a boot sector virus or any other kind, or there just might be an impending drive failure. But any kind of disk configuration when it comes to partitioning, you need to make sure that you've done that correctly and that all the partitions are set with the correct specifications. Bad sectors, again, that's one of the most common issues, and that is usually a mechanical issue with the drive or the hard disk surface itself. You typically need to run a diagnostic utility to be sure of that, but bad sectors will always pop up in almost every environment. Cache issues. The cache, again, is always just memory, and it's powered by battery, so there might be a battery failure, in which case you're going to probably get file corruptions, because the whole idea behind caches is that information that's being written is temporarily stored in the cache because the memory is so much faster. But as far as an application is concerned, once it is in a cache, the application believes that it has been successfully written to the disk. So if the battery fails or any kind of power supply for the cache fails, the information, in fact, is not written to disk and it can become lost. So, portions of the file may still be residing in the cache at the point where the power failed. The cache might simply just get turned off. Now, if it is, it's probably going to continue to work in what's known as write-through mode, which simply means bypass the cache. Don't store anything in the cache, write directly to disk. Now, that's fine, but it does reduce your performance because it's going to take longer. But that being said, most database applications, just as an example, generally want you to turn off the write cache because of the problem I just mentioned. The application, the database, believes that the information has been written to disk when in fact it's only sitting in the cache. So again, if you lose power to the cache, that information is gone and you've lost those records. So a lot of database applications, again, do actually suggest that you turn off any kind of caching on the write side of operations so that it goes straight to the disk. Some other problems, obviously insufficient disk space. If you have somewhere in the neighborhood of 80% full or greater, or if the files are very fragmented, performance degradation will occur. And once you do get up to 80% full, again, it's a bit of a snowball effect. It's very unlikely that you're going to be able to find enough contiguous disk space to write particularly very large files. So you end up with a bunch of fragmentation happening as information is written. So the more full your disk becomes, the more fragmented it usually becomes as well. And of course, if you do have a RAID configuration, then always need to make sure that it was properly configured, that all of the disks are correctly configured within the array and all of the fault tolerance was implemented correctly and so on. Mismatched drives can increase drive stress and degrades performance. So particularly, again, if you do want to define some kind of an array, ideally you want the same disks. Now, you don't have to. It will work, but you typically want the same specs, the same sizes, the same I/O times, basically identical drives if you can, for best performance. Backplane failures, ensure the correct seating. Again, make sure everything is physically attached and screwed down. And you just want to make sure that all the power signal cables are attached appropriately. And again, on both sides, obviously to the drive end and to the motherboard end. So you just want to make sure everything is secure. all screws are in place and that nothing has been knocked loose, particularly after some kind of a maintenance cycle or things like that.